Hello, and welcome to the Data Science Model Selection Part 2 video, where we're going to be talking about objective identification. My name is David Little. I'm with the Unit for Data Science and Analytics at the Arizona State University Library. And let's go ahead and get started. There's a lot of models and a lot of problems. There's just as many problems out there as you could possibly think of. There's an infinite number of problems. So kind of that first question that comes to mind is, what do we need to do? What are we trying to accomplish here? So it can be a little overwhelming at times when there are so many models and so many algorithms and so many things to choose from, especially if you're first starting out. But again, just to reemphasize, the first thing to really do is identify your objective. So at this point, usually with your problem, you've either thought through it, if it's a problem of something you want to solve, or you've ideally sat down with the subject matter expert or the person who's really trying to answer a question. And you sat down with them and you've talked them through, okay, what are we trying to figure out? But I find that there's about 5 main categories that I see are very common in data science problems. They are supervised learning, unsupervised learning, dimensionality reduction, anomaly detection, and time series analysis. So supervised learning is really all about prediction. So classification models, regression models, even some of the neural networks, really when you're just trying to predict something in the future or into an unknown space. So if you think back to elementary school or high school mathematics, you've got your X and your Y axis. So supervised learning is all about, I'm trying to predict some sort of Y value using my X values. This is really common in a lot of science, in a lot of situations. This is kind of one of those first and foremost things that you're trying to look for. The next category is unsupervised learning. And what that really has to do with is the most common is clustering algorithms. So you're trying to group your X values without a Y. So you don't care about predicting something. You just want to see how the data kind of groups together naturally, quote unquote, naturally. And so the big difference between supervised and unsupervised learning, you're trying to predict a certain value, a certain X. Unsupervised learning, you don't have that. You just got a bunch of values. So clustering is really common among marketing-based problems. So you're trying to group people or, features about people into certain categories. Or maybe you've got some kind of like weather data and you're trying to find certain types of weather patterns that tend to group together into certain features, that sort of thing. So once we kind of pass through supervised and unsupervised learning, we talk about dimensionality reduction. So commonly this is talked about as principal component analysis. Random forest importance is another example. If you don't know what those mean, that's fine. The important thing with dimensionality reduction is this is a situation where you have a lot of X's. So if you want to think of it as like a spreadsheet and you've got your Y value, let's say it's a category of a person type that you're interested in, and your X's are just all your different attributes about each person. And you're almost overwhelmed with how many that you have. With a lot of models, you only need a handful of values to really understand or best predict your Y. So in this instance, you will take all your X's and you want to boil them down or reduce them down to a smaller set of features that are important, not necessarily the full picture. This really helps with simplifying your models, or if you've got situations where having so many values overwhelm your computer and you can't run the full model. This is a good example of what to do in those situations to kind of simplify your problem. So the next example is anomaly detection. This is really common among cybersecurity or financial security sort of situations. And this is where you're trying to find the odd one out. It sounds much more simple when you kind of say it out loud, but it can be hard to detect some of these values that are odd or statistically significantly different than the rest. So, this is trying to find a fraudulent transaction among your transaction history. What of your behavioral patterns does, a certain value seem out of place, in which case it could be, credit card fraud or whatever. Last but not least, time series analysis. Weather is very commonly a time series analysis, temperature over time, and another big time series analysis category would be finances or stock prices. And time series analysis, self-explanatory. This is you're trying to look at things over time. A big piece or a big component of time series analysis that is often taken into consideration are cyclical patterns. So, in the summer, it's hot. In the winter, it gets cold. And you get this kind of sine wave sort of pattern in your temperatures. And time series analysis kind of takes those into consideration so that you can predict, okay, next summer, what will it look like as far as temperatures are concerned? That about sums it up for the different types of main problems. Now, also keep in mind, this is not all encompassing. Every project that you're approaching should be kind of approached uniquely. Keep an open mind about what you're trying to do, be creative. But, these are some basic guidelines that might help point you towards a certain way or certain route to go to start off. We'll talk a little bit more later about other options that you can do, such as, trying different models and seeing how they come out. But this is a great place to start. That's it for me for today. Thank you guys so much, and looking forward to seeing you in the next video.